So we've looked at matrices before and how to organize them. But now in today's video, we're going to look at matrices and how they can help us solve system of equations. Now before we can talk about how matrices can help us solve us with equations, you have to talk about row operations, which are ways we can legally change a matrix and they'll help us solve system of equations later on. So I know this page is really chaotic. I just want to throw some examples up for you guys. So for this first one right here, we can interchange any rows. All I'm doing here is switching my row 1 with row 2. It's being row 1, it's being row 2. Okay, and now we'll have row 2 on top, and row 1 on the bottom. So that's what that first one's doing. The second one is we can multiply any row by some non-zero multiple. So in this first example, I'm multiplying 2 by the top row, and I represent that by multiplying a 2 next to the row that I want to multiply. And so this 2 is going to be distributed to the 1 and the 2, and so therefore we'll end up having a new matrix 2, 4, and 3, and 6. Now I can multiply even by fractions and negatives, because the only requirement is this has some non-zero multiple. And so when we multiply by negative 1/3 to our 3 and our 6, we'll end up getting that 3 times negative 1/3 is negative 1, and 6 times negative 1/3 is 2. Okay, so those are pretty explanatory. This is one that's kind of tricky, and that's where you can add or subtract any column or any row to any other row with some constant multiple with that column. And so what does that mean exactly? So here we're going to break apart our 2 rows, first and second. All right, now what it means is that we can add any row to our other row. So here I'm adding the second row to the first row. So here 3 is going to be added to the 1, so it'll be moved up there. And then we're adding a 4 to our 2. And so we'll get 1 plus 3 is 4, 2 plus 4 is 6. We get our new matrix. We can also do the same for our other row. We can add the first row to our second row. So to do that, this 1's going to move down here, and this 2 is going to move to 4. And so our matrix is going to change to be 1, 2, and then 3 plus 1 is going to be our 4, and then 4 plus 2 is going to be our 6. Okay, but now the fun part, where we can actually throw a multiple in front of our row that we're adding or subtracting from our other row. So anyways, here what's going on is that we're subtracting 2 of our second row. And so our 3 is going to be multiplied by negative 2, and so it's going to be 1 minus 2 times 3. And here it's just going to be 2 minus 2 times 4. And you just see now the only difference is that those have a multiple in front of each one of them. Okay, now our matrix is going to change. 1 minus negative 2 times 3 is negative 5. 2 minus negative 8 is 6. And the bottoms are going to stay the same. Let's look at another example of where we add the columns, just to make sure we've got it down. Okay, so for this one, we're adding 2 of our second row to our first row. Okay, so what's going to happen here? So we're adding, put a plus sign right there, 2 of our second row. So here will go our first element of our second row. We times that by negative 1. Okay, now we have to do the same for 4. So we're going to add 2 and put in our element from our second row. It'll just be 2 right here. Okay, So what's this end up equaling? So that's just going to be 2 plus negative 2. So we'll have 0 right here. And then we'll have 4 plus 4 is 8. And our bottom row stays the same. Okay, but now we've already done one. We can even do another. We can just subtract row 1 from row 2. Now, what happens when you do that? And I'm going to erase, give myself more room. Show you guys. There we go. So here we're subtracting row 1. Okay. So what's going to happen now? Okay, so we're subtracting our first row from our second row. So here, we're subtracting 0. So 0 goes into here. And here, we're just going to be subtracting 8. Okay. So what will that end up being? And by the way, once you do row operations, I like to make arrows to guide you onto the next matrix. This helps you stay organized and helps you follow your work. So anyways, first row isn't going to change. The second row, -1 minus 0 is just -1. And then 2 minus 8 is going to be -6. That's our new matrix. All right, so those are our 3 row operations. Now to help us solve these system of equations later on, we're going to have to put our matrices into row echelon form. Now what is row echelon form? So it looks like either one of these matrices. And the goal here is to get your pivots or all your diagonal values to be 1. And everything below this diagonal, or your like lower triangular, or triangle if you may, should be 0. So your diagonals are 1, and everything below your diagonal is 0. Now the goal here is to get your first element of your first row to be 1. So here we want to get this one to be 1. Now that we've gotten that one to be 1, we can make these guys turn to zeros pretty easily. Okay, and then now once we've gotten that first element to become 1, and the ones below it to be 0, we look onto our second element, or our second column, and the second element of that one, just kind of like a middle value, and get the ones below that to be 0. And then in our 2 by 2, will actually be done once we get it into this form. By the way, I know I forgot to mention this. A, B, and C, they're just some random numbers. You'll end up getting them to be there after you do your row operations. Those can be any numbers. So that's what those represent. Yeah, and so once you've gotten all your zeros, all I have to do now is get this last one to be 1. So those are your steps. Get a 1 in your first row, first element, get zeros below that. Then move on to your second row, second element, get zeros below that, so on and so forth. Okay, well, let's look at an example. And let's start off by a 2 by 2. How do we get this to be in row echelon form? Okay, so we want the first element to be 1. And you can already see that this guy is already 1, right? So let's just interchange the rows. It's going to save us some work. Okay. So when we do that, and I'm getting 1, 4, -3, 2. Okay. So now we got a 1 and our first row, first element. Okay. Now the next step of that was to turn this guy into 0. Now how do we do that? Well, we see if we add the first row to the second row, and multiply it by 3. I'm going to erase all this right quick and give us some more room. And now, so yeah, if we add 3 of our first row, it's going to get rid of this negative 3, right? Because we're adding 3 times 1. Now 1's going to go right there. And here, we'll be adding 4 3 times 4. 4 goes right here. All right, so the reason why I added the 3, or the 3 from the first row to the second row, is to turn this negative 3 right here into a 0. Okay, now that's going to happen when we do that. So we'll have 1, 4, 0. And now 2 plus 12 is just going to be 14. Okay. So we got a 1 right here. And you got zeros below it. So that's good so far. Now the only thing left to do is turn this guy into a 1. And the best way to do that is just multiply this by 1 over 14. And so when we do that, our first row isn't going to change. And then that 14, well, 0 times 1 over 14 is just 0. But now 14 times 1 over 14 is just 1. And there we have it. Got 1s in our diagonal and 0s underneath them. So this is REF, if you may. Okay, now let's do something a little bit trickier. Let's look at a 3x3 matrix and try to solve this guy. Okay, so I know we haven't looked at a 3x3 matrix before, but it's in essence the same thing, just has more elements, more rows, more columns, but everything stays the same. Okay, so here we can interchange the second row with the first row, but I'm just going to divide this whole row by 2 or multiply by 1/2. You can do it either way you want, whichever you feel preferable. There's really not one specific way of doing this. You just have to kind of get a feel of how to do these. And just the most important step is to get your first element of your first row to be 1. So I'm going to give myself some room before I start doing this. Okay, cool. So we got a 1 right here. That's done. Now we just got to get these guys below them to be 0 and 0. Okay, now how do we do that? Well, if we see here, if we just subtract our first row, we'll end up getting this guy, this first element of the second row, to be 0. Now let's do that. Okay, so we're subtracting our first row. So just be subtracting 1. Here we'll be subtracting 2. Here we'll be subtracting 3. Our new matrix will be 1, 2, 3. Top row won't change. 1 minus 1, 0. Cool, so we did our job. 3 minus 2 is 1. All right, so now we're looking ahead. We already got that middle point to be 1. And then 2 minus 3 is negative 1. And so now we haven't done anything with this last row yet. But we still need to change that 3 into a 1. Okay, so remember how I was saying turning this first element, this first guy right here, to a 1 is going to make it a lot easier to get zeros underneath. Because now, all I have to do is subtract 3 from the first row. Okay, so when we do that, we'll have minus 3 times 1. So 1's going way down here. Then minus 3 times 2. So going into there. And then minus 3 times 3. Okay, so what do we end up getting? And then here, we'll end up getting 0, which is just what we wanted. Negative 4 minus 6 is negative 10. And then negative 5 minus 9, which is going to be negative 14. Okay. All right, so now we got to turn this negative 10 into a 0. And now that we've turned this guy into a 1, it's going to help this negative 10 turn to a 0. So all we have to do here is add 10 times our second row. You see that? Because 10 times 1 is just going to be 10. And so here, we'll add 10. And now negative 1 plus 10, it's just going to be minus 10. Okay, so then we'll get our matrix to change. Top row stays the same. Middle row stays the same. And then bottom row, got that 0 just like we wanted. And now we just have this negative 24. Okay, though. Only one more thing to do is to turn this negative 24 into a 1. To do that, all we need to do is multiply this by negative 1 over 24, right? Or divide it by negative 24. And then we'll have it. All right, perfect. We got all the diagonals to be 1, just like we wanted. We got nothing but zeros underneath it. So this is our REF form. All right. So I know a 3 by 3 matrix is a lot, but it's totally better than solving a system of equations with 3 equations and 3 variables without using a matrix. So anyways, can we turn an augmented matrix into REF form? And now what this is asking is, when we write our system of equations into a matrix, can we REF it and help us solve it? And the answer is yes, we can. Just now we have this equal sign right here, if you remember, in our system of equations, in here. And so we're still going to want ones in our diagonal, but over here you'll just have numbers. Okay. So why are we learning this? Well, let's look at this example. How do we solve system equations in matrix form? So first off, let's put this into an augmented matrix. So negative 4, negative 4, and we draw a line, 15. And we'll have 2, 5, and 20. Okay, so now let's put this guy into an REF form, or row echelon form. Okay, so what I'm going to do first is multiply this top row by 1 over 4, because multiplying negative 4 by 1 over 4 will turn it into a 1. Okay, so when we do that, 1 over 4 times 1 is 1. we'll end up getting 1 times 1 all over 15 divided by 4. All right. Can't reduce that fraction at all. And the bottom part is going to stay the same. All right, but now we need to turn that 2 right here into a 0. And now to do that, we can subtract 2 of our first row. Now let's do this. Okay, so I'll have subtracting 2 times 1. And that 1 into there. Subtracting 2 times 1. Now we also have to do the same for everything that's augmented. So here we'll have minus 2 times 15 over 4. Okay. So when we do that, end up getting the first row stays the same. And then 5 minus 2 is just 3. And so 20 minus 2 times 15 over 4 will just end up being 25 divided by 2. Oh, trust you guys knowing how to subtract fractions. So I'm not going to show you guys how to do that. Just, common denominator. Okay, so anyways, now we just got to get that 3 to be a 1. So we just multiply this whole thing by 1 over 3. Okay. So when we do that, our matrix is just going to change to 1, 1, 15 over 4, 0, 1, this is the important part, then 25 divided by 6. All right, we've done it. We've turned this into our EF form. Okay, so now for the last part. I know this video's been going on for a while, but this is the most important part and what we're trying to get to the end, or what we're trying to learn from the end of this video. What this matrix is saying now is that remember, these are coefficients in front of your variables. These being your coefficients right here. Now, we take these coefficients here, we can say that that's equal to x plus y is equal to 15 over 4, and then 0 times x, which just ends up being 0, so we can get rid of that, times y. So remember, these all have 1s in front, but anyways, just want to make sure that's clear, is equal to 25 over 6. Now, the reason why we've turned it into row echelon form is because, boom, we've already solved for y. Now, once we solve for y, all we have to do is plug our y back into this guy up here. Okay, so y is going to be 25 over 6 is equal to 15 over 4. And so now all we do is subtract 25 over 6 from both sides. We'll get that x is equal to negative 5 over 12. So yeah, when you plug your x and y in, you should get your answer back. However, I realized when I was going through this that I made one small mistake. And here, I should have multiplied this by negative 1/4. And so that way, this would have been negative 15 over 4. And that would have changed a couple of things here, right? Because here, now this would have been plus instead of minus, and so on. So anyways, that was my small mistake. But other than that, everything else is correct. I hope that made sense. I'm sorry for that confusion. But anyways, so thank you guys for watching. I know this was an extremely long video, but anyways, this is some important stuff that we had to cover. And now that we cover it, we should be able to solve system equations that have 3 equations and 3 variables in it now with matrices. Anyways, I posted a question in the blog doing with REFing, and I want to hear you guys' responses on it. But anyways, thanks again for watching.